All right, so we are back, and what I wanted to say was that this is going to be x, and that is x full length, but then there's a 1. So that means we are going to do this partial length, which is going to be x minus 1, or we can just say it is x. So there's two ways we can write this. So if I write this, oops, that is not very good. So if I write this, this is x, and that's our 1. We can say this is x minus 1. This right here, this length right here is x minus 1. And then we can have the 1 there, but then just realize that if I added those together, if I added, let's say, this and this together, that would be x minus 1 plus 1, which would just give me x, because a negative 1 and a positive 1 would cross out. So it would just equal x. So there's two ways you can do this. You can write this and say, hey, this is x minus 1 for this length right here. And then I have to add the 1 here, but that still just gives us this length of x. But if you want to just do the length of x, you cannot do that. So it depends on what you want to do. I personally like the shortcut way. So if I'm given something like this, I just know that that length is x, and I do not include this side. But if you wanted to include that side, you do x minus 1 plus the 1, which would give you x. So one more time. So we have x, we have this, which is our 1. So we have 1, 1, 1, x, 1, 1, and this right here would be x minus 1. So if I add this all up, that would be x plus parentheses x minus 1 plus 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's going to be 2 x's. So I take my 2 x's here. So that's 2 x's. And then 1, 2, 3, 4, 5. But that's a subtraction of 1. So that's going to be 2x plus 4. Now if I did it the other way, and I just said that this is x, and this side is also x. That's also x. Then I'm going to go ahead and just calculate my 1, my 1, my 1, and my 1. So that means I have an x here and an x here. So that's 2x and 1, 2, 3, 4. I don't include this side because I'm already including it as that's the length of x. All right. I hope that makes sense. We're going to go on a few more problems. I lost my train of thought or track because now my paper's all over the place, so I apologize for that. So I'm going to fix that up right now. So let's go ahead and do this. So we're going to be at C, and I'm going to have this giant square, which is y squared, and this other big square, which is x squared, and this little nub, which is 1. So this is y, 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 because every side is y. Now again, the little trick here is this side is y. So if I'm including this entire length of y, I'm not going to include this. I'm not going to include that because that is the same thing as that. So it's the same thing. So I'm going to do the shortcut and say that's y. Then I have 1, 1, 1. And now since this area right here is x but minus 1, I'm not going to include this side. I'm just going to say that that's x and include this whole length right here and say that's x and x on top. And then you're done for the most part. And then we have this part right here, which can be kind of confusing because actually, no, I already measured the y, so we're good. So I'm going to go ahead and add them up. So I have my two sides, y and y. So y plus y. Then I have the top and the bottom plus y plus y. And then I have x on top and the x on bottom plus x plus x. And then I have two 1's, plus 1 plus 1. Add them all up. That's 4y, because I have 4 groups of y. I have 2 x's, I have 2 groups of x's, and then plus 2. And that is one way that you can do that. If you wanted to even go crazier and more simplified, you can actually distribute out of these numbers. What do they have in common? Which is a 2. So I can say that there's 2 groups of 2y plus x plus 1, if you wanted to do that, but you don't have to. All right, again, if I wanted to, I'm not gonna waste too much time. I'm just gonna keep going straight to it. I don't know what that button is. That screencast-o-matic, that's launched. I'm sorry. Give me 1 second as I pause. If I can find the pause button. I'm sorry. I don't know where my pause button is. Well, looks like it's gone. So we're just going to run through this thing. All right, let's finish this up. Moving down to D. So for D, I have D is going to be x, y, plus another y, plus another y, plus another y. That's a y. And then we have this long x. All right, so that is what we have for D. And this is going to be our last one for 2.12. I want to speed this up. So we want to make sure we understand that the length going this way is x and x. So that's x here and here. The height is y. So that means this is y. That's a 1, a 1, a 1, a 1, a 1, a 1. Now again, I'm going to do the shortcut. Take this whole length right here, which includes this length, and I'm going to make that y. And then that's pretty much it. So I included every single length here. So let's go ahead and circle y2. So that is going to be 2y plus x, 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 x. That's 4 x's. Plus 1, 2, 3, 4, 5, 6. And that is what we're going to do. If you want to go crazy, you can reduce that and go 2 plus y plus 2x plus 3. And the other rule is that you usually want to put your more valuable variables in front. So it would be even more simplified in terms of this, which would be 2x plus y plus 3, because that one has a bigger number. Don't ask me, don't make the rules, I just follow them. All right, that's pretty much it. We're going to pause real quick and I'll get us started on, well, we can't pause because I don't know where my pause button is, so we're going to go straight on to 2.13. And now we're going to go ahead and go to 2.13 if we can do this. So we're going to cross this out. So 2.1.3, algebraic expressions. All right, algebraic expressions. Let's go ahead and get this started. We are going to get going on problem number 223. All right, 223. This is really good because we're going to be talking about positive and negative values. All right, we already talked about, we understand there's positive integer tiles and negative integer tiles, but there's also positive and negative algebra tiles. So here, just so you know, this is going to be 1. So if I had, and make sure it's shaded, so that's the thing. Shaded is going to be, let's see, that's 4. Not shaded is 1. That is negative 4. If I had x, and I know it kind of sucks because we already did x and all these things, but yeah, shaded is positive, and then unshaded is going to be negative x, so we'll have to get into practice of that and the same thing. And I really would like you to shade and not shade negative y. All right, so let's keep going. I don't know how much time is left, so we're just going to go until we can't go anymore. This is an expression mat. There's positive sides and negatives, and there's going to be a few things that we can do when we write our tiles. So here we have 3 negative tiles in the positive region, which means they're negative 3. And then we have 3 positive tiles in the negative region, which means it's actually negative 3. So they actually equal the same thing. And we want to make sure that you understand that these are examples of a positive region and negative region that counteract. So in terms, let's just say I'm going to write this out. So I have a positive and a negative, and I want you to write this as an example. If I have 1, 2, 3, I have a positive negative 3. So that's going to equal negative 3. But if I also have my algebra tile mat, and I have 1, 2, 3 tiles there, I have a negative positive 3. Well, a negative and a positive right next to each other equals a negative, so that's still going to be negative 3. And that is why. All right? So we're going to be talking about a few things here. Let's go on to 2-23A and build two different expressions for negative 2x. Again, pause the video if you can. Try to do this on your own and see what comes up. But two different expressions for negative 2 using expression mat. So I'm going to go ahead and say that this is my positive, this is my negative. I have negative 2x. There's 1x, there's 2x. So that's positive negative 2x, which equals negative 2x. And then another one is going to be positive negative, and I'm going to put x. And I'm going to try to shade it as best as possible. And that is going to be negative 2x, which is negative 2x, because they're two positives in a negative region. So that's going to be it. Similarly, build 3x minus 4. So we wanted to build negative 2x here and here. So we're going to do for b, we're going to build 3x minus negative 4. And how many different ways can you build 3x minus negative 4? So we're going to try a few ways. So the first thing is this can go into a negative 3x, or it can be a positive 3x. So those are the two ways that we can do that. So that's 1, 2, and then we'll just say that this is going to be minus, which is going to be subtracting negative 4. And so that means we would be in the negative region of negative 4. And then we would also be in the negative region of negative 4. So I'm going to go ahead and build one right here, just so you understand, positive, negative, and that is going to be nothing in the positive, and then we're going to have 3 x's, 1, 2, 3 x's, and 1, 2, 3, 4. So that means that we have a negative 3x minus negative 4. So again, these are negatives, negative 4, these are negatives, negative 3, and they're all in the negative region, here and here. So that's what that means. And if I wanted to do number 2, I would just take those 3 x's that are negative and put them in the positive. And I'll go ahead and do that right now. And actually, let me move my thing up a little bit. So then I would have, and this would be x, 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 and it would be positive. So I'm going to fill those in. And the bottom would have 1, 2, 3, 4. So again, this is going to be positive 3x, because I have 3 positives in the positive region. So positive, positive. But we don't need to put positive, positive. We can just leave it like that. Minus negative 4. And so that's another way that you can do it. Again, 2 negatives here make a positive. Minus negative 4. And then you can do the same thing on the other side. So this would be 2 here, and then this one would be 1 there. And there's more than 2 ways you can do it. You can do it 4 ways. You can change the negatives here, etc., etc. But for time purposes, we are going to go on to the next one, which is, oops, shouldn't have done that, but 224. And we are going to, did you see all the different ways to represent minus that you listed in problem 222? Or actually, we didn't do 222, so we're going to skip that and go to 225. Use the expression mat to create each of the following expressions with algebra tiles. Find at least 2 different representations. Perfect. So this is what we're going to do right now. A, negative 3x plus 4. What we're going to do is I'm going to have my mat, another mat, and I'm going to make 2 different ways. So the first way is, well, I kind of already did this a little bit. I'm going to go ahead and